to you by the Panasonic Air Conditioning Group. This video covers the installation guidelines and procedures for the VRF heat pump and heat recovery systems. ECOi systems allow multiple indoor unit combinations that provide you with the utmost and flexible solutions. Heat pump and heat recovery systems allow for multiple unit connectivity between 50% and 130% of the total capacity of the condensing unit. The U36, LE1U6, can connect up to 6 indoor units, and the U52, LE1U6, can connect up to 9 indoor units. Both of these units are heat pumps. 1 U72, ME1U9, or 1 U96 ME1U9, heat pump unit, connects as many as 17 indoor units. 1 U72, MF1U9, or 1 U96 MF1U9, heat recovery unit, also connects as many as 17 indoor units. The U, ME, and the U, MF, can combine up to 3 outdoor units for a total of 24 tons. Heat recovery units can provide simultaneous heating and cooling. Heat pump units can only provide heating or cooling to the indoor units. The outdoor unit is capable of varying system capacity from its full capacity, down to 20% of its rated capacity. Indoor units are also capable of modulating down to 20% of their rated capacity. This is accomplished through the use of one inverter-driven rotary compressor, and one fixed-speed compressor along with electronic expansion valves located in each indoor unit. ECOi heat pump and heat recovery systems are applied products. They are well suited for many types of applications. The following items should be completed by a designer who has been trained and certified. Step 1 is to perform an initial building survey to determine feasibility and equipment locations. Step 2 is to perform load calculations and equipment selection. Step 3 is to determine final equipment locations along with piping lengths, power, drain, airflow and customer requirements. Step 4 is to design a Panasonic piping and control system layout, if needed, and interface to building automation systems as required. And Step 5, provide detailed plans and specifications of the installation project. Outdoor units and installation procedure. There are several outdoor unit models available at this time. The U, LE, and the U, ME, are heat pumps. The U, MF, is a heat recovery unit that is capable of delivering simultaneous heating and cooling. The U, LE models are 208 to 30 volt single-phase power. The U, ME, and the U, MF, models are 208 to 30 volt 3-phase power. The U, 36, LE, is a 3-ton unit, and the U, 52, LE, is a 4.3-ton heat pump. The U, ME, heat pump and the U, MF, heat recovery units are available in 6 and 8-ton. Model numbers are based on the condenser cooling capacity. When deciding on a location for the condenser or condensers, you should choose a place that is as cool as possible, and be sure to avoid any heat sources, damp, humid, or uneven locations. Allow enough room for airflow and future service. Always anchor the unit properly to reduce noise and vibration. When you are installing a condenser in a moist or uneven location, use a raised concrete pad or blocks to provide a solid, level foundation. This will prevent water damage and abnormal vibrations. In areas that are subject to high winds, securely anchor the outdoor unit with bolts to a metal frame, and provide an air baffle. Snow drifts can also affect the performance of the condenser. To avoid this, install the unit on a raised platform and provide snow vents. In areas prone to high snow amounts, it is important to use snow shields and wind baffles. Wind baffles are available for the U, LE, but all others are field fabricated. The dimensions can be found in the installation manuals. This is a very good example of the use of snow and wind shields. Notice how the units are also elevated to allow for snow, ice buildup and defrost drainage. Let's look at the minimum clearances of a U, LE. Please note that in Figure 2, the units with the discharge air in the same direction should have a minimum of 80 inches of clearance. the discharge side of the Mini should have a minimum of 40 inches of clearance. The compressor side of the condenser should have a minimum of 12 inches, for future maintenance and repairs. The back side of the unit should have a minimum of 6 inches to allow sufficient airflow over the condenser coil. Please refer to the installation manual for the minimum clearances of a U-ME, or a U-MF condenser. As a guideline, the service panel must have at least 20 inches of clearance for future maintenance and repairs. For proper airflow around the condenser, you should maintain at least 12 inches. When combining condensers, in some situations you may place the condensers as close as 4 inches apart. The outdoor unit is capable of being installed in a suitable indoor location if your local codes permit. Discharge air may be conveyed outdoors through duct work. Be sure not to exceed more than 0.25 inches of water column for external static pressure. If ducted, please provide a means for the introduction of adequate ventilation air to prevent negative pressurization of the room or building. Remember to provide a drain pan and drain lines under the unit for the defrost cycle. Let's take a look at the air handlers available for Panasonic VRF system. Panasonic offers a variety of indoor units and they all operate on 208 to 30 volt single-phase power. The MD is a semi-concealed ceiling unit with a one-way air throw. The MK is a wall-mounted unit. The MU is a semi-concealed ceiling unit that has a four-way air throw. The MT is a ceiling suspended unit with a one-way air throw. The ME is a medium static concealed ceiling unit, and the MF is a low static concealed ceiling unit. The MM is a low profile, low static concealed ducted unit. The MR is a floor-mounted unit that does not include the decorative panel. And the MP is the floor-mounted unit that includes the decorative panel. The wall-mounted model can have the refrigerant and condensation lines exit from the left, right, or back. The minimum height from the floor is 5 feet. Be careful to run the condensation line as low as possible so that the pan will drain properly. Do not use P-traps on the drain, but if they are required, install them as low as possible so that enough head will build to push the condensation through the trap. The MF concealed units have 2, 3, or 4, 8-inch duct collars. These collars may be removed for use with a plenum that is field fabricated and attached. The amount of duct work you can attach is limited by the static pressure ratings for the model being installed. You must stay within these limitations to maintain proper airflow. The external static pressure is adjustable by using the included booster harness. These units are typically suspended with threaded rod. To achieve higher airflow, with the MF concealed unit, there is a fan booster harness supplied in the electrical compartment. This cable is installed between the fan harness and the circuit board harness. It increases the RPM of the motor. The MF concealed unit comes from the factory set up to use the rear return, but the bottom panel can be moved to the back of the unit to allow for a bottom return. A filter and rack are field supplied. If needed, the electrical compartment can also be moved to the opposite side. Conditioned outside air can be ran into the return of all ducted models, but this can have a negative effect on return air temperatures and control. It might become necessary to relocate the return air sensor to a location in which it is not affected by the incoming outside air, or change a setting to allow the local controller to sense temperature. The unit is set from the factory to sense space temperature from the return air. The MF has a built-in condensate pump. The discharge is located near the top of the unit. The lower plug can be used to drain the unit of a coil cleaning solution. The ME concealed units have higher static pressure ratings. They also have no internal condensate pump, but there is a built-in float switch. This is the only model that requires a P-trap in the drain line. The filter and rack are field supplied. The MD, MU, and MF units have built-in drain pumps with limited lift ratings. Please refer to the installation manuals for each specific model. Units with built-in pumps also include float switch safeties. Power requirements and control wiring. This is an example of the wiring typically found on the indoor unit. All indoor units require a 208, 230-volt power supply, and it is not uncommon to connect as many as 5 indoor units on one power supply circuit, if permitted by your local codes. Disconnects are not a Panasonic requirement, but are usually required by local codes. 18-gauge, 2-wire stranded shielded cable, is required for all control wiring. The shielding of the wire should only be grounded at one end, which is typically connected at the outdoor. There are 2 acceptable methods of running the control wiring. The daisy chain method shown is the recommended configuration. Starting at U1 and U2 of the outdoor unit, connect the first indoor unit to U1 and U2. Continue this daisy chain method and connect to each indoor unit. Twist the shielding of your control wire together at each indoor unit, but only connect it at the condenser. The U1 and U2 control wiring is also referred to as the S-net. The S-net control wiring is not polarity sensitive. The branch method is also acceptable, however, the daisy chain method is recommended. It's much easier to find a break in the wiring if you ever had such an issue, and has less restrictions than the branching method. This example shows one of the most common wiring mistakes. R1 and R2 are the remote controller connections. If your outdoor unit was set to 5 indoor units, as in this example, it would only see 3 units, and you would get an error code. If you lowered the outdoor unit settings to find 3 indoor units and no error codes are reported, then you would know the problem was between the 3rd and 4th indoor unit. If the units were wired using the branch method, you could not use this method because the units are not wired in series. Another common mistake is using standard T-stat wire, instead of using shielded wire. This can cause noise, intermittent, or complete loss of communication. A good way to check for a break in the control wiring is to check the ohm reading anywhere on the S-net. Between U1 and U2, you should read about 100 ohms. This will not help determine if the power is off to an indoor unit, or if the control wires are landed properly. The use of star wiring is not permitted and should never be employed when installing ECOi equipment. Do not loop the S-net control wiring. If you were to make this mistake, the system would never be able to address. Here is another example showing the control wiring for a typical system. If one leg of your 3-phase power supply has a higher voltage reading than the other 2, this leg should always be landed on L3, which is labeled T, at the high voltage terminal block in the condenser. This is commonly called a wild or stinger leg. In this example, we have 2 condensers combined. They are connected via the 3 and 4 terminals on the condenser. The condenser that has U1 and U2 connected to the indoor units is always set as the main unit. The 63 series can combine up to 3 condensers. Sub-units are always connected via the 3 and 4 terminals. Indoor units number 2 and 3 are in group control. The air handler that has the wired controller is always set as the main. R1 and R2 are daisy chained from the main unit to the sub-unit, or units. You can control up to 8 units in group control with a wired controller. In this example, there are 2 wired controllers on a single air handler. The last input on either controller will be the command that the air handler will follow. If you have a heat pump system, you can set any controller as a priority controller. When a controller has been set as the priority controller, the mode function is locked out on all other controllers. There are several local and central controllers available for ECOi systems. Shown are the different types of wired controllers and central controllers available. The CZRTC2 controller can control up to 8 units. It includes a 7-day timer with up to 6 functions per day. The simple remote can also control up to 8 indoor units. But they do not have any timer functions. The remote sensors do not have local control functions, they will only sense temperature for the air handler. The system controller is a central control device that can control up to 64 indoor units. It does not include timer functions, but it can be set to prohibit local controller functions. For example, it can prohibit a local controller from turning on or off, changing set point, or modes. The intelligent controller is a central control device which can control up to 128 indoor units. It has a touch screen and it is web-enabled. It can perform all of the functions allowed by the other controllers. These central controllers are typically installed in a secure area such as a manager's office or a maintenance area. No local controller is required when using a central controller, but both can be used if desired. All local controllers should be connected using 18-2 shielded, stranded wire, and are connected at the R1 and R2 terminals of the indoor unit. All central control devices should be connected on U1 and U2 of the terminal block. This will allow the device to monitor and control all of the refrigerant circuits. All ECOi air handlers can use wired or wireless controllers. These are the wireless kits available for the ECOi air handlers. Refrigerant piping, evacuation and charging procedure. The Panasonic designed software is used to create piping and wiring diagrams for each job. These drawings will be provided by your Panasonic representative. All Panasonic 410A condensers use 5/16 gauge port connections. You will need one of these adapters in order to connect gauges to any Panasonic unit. It is suggested that soft-drawn, ACR-grade tubing be used in all installations. This will minimize equivalent length of tubing run and leak potential. Hard-drawn tubing may be used. If necessary, use long-radius elbows. 15% silver brazing material is recommended on all solder joints. A 1.5 to 2 psi nitrogen purge must be employed during brazing operations. Factory-supplied distribution joints, which are purchased separately, must be used where specified. Field-installed ball valves, with access ports, are recommended on both refrigerant lines entering an indoor unit. If a nitrogen purge is not used while brazing, oxidation will occur and contaminate the system. Do not use dryers or sight glasses. Dryers can temporarily be installed in a contaminated system, but they should be removed once the system has been cleaned. Dryers should be correctly sized and rated for use with R410A and POE oil. Condensers will be sweat, flare, or a combination of the two. Remember to evacuate the oil equalization line when condensers have been combined. When ball valves are used, install the gauge connection port towards the air handler. Remember to open the valves when evacuating the system, and do not forget to remove the Schrader core when brazing. You should only use Panasonic supplied distribution kits. Part numbers and locations will be on the piping diagram. They come with formed insulation which cannot be ordered separately, so be careful not to lose them. If you do misplace them, you could create your own with sheets of insulation. The distribution joints should always be installed in a vertical or horizontal position, and have a pitch of 15 to 30 degrees of rise on the long radius 90. If the air handler is installed above the distribution joint, the tilt is not necessary because the oil will naturally return back to the condenser. All ECOi units have an oil recovery cycle, but proper piping pitch will keep this feature from occurring too frequently, and increase system efficiency. The single end of the distribution joint should always point towards the condenser. There is only one exception to this rule. When there are multiple condensers piped together, the single end of the distribution joint should always point towards the indoor units. This example shows an installation with the condenser below the indoor units. All refrigerant lines must be insulated, and the insulation thickness should be no less than 5/16. In this example, the condensers have been installed above the indoor units. Always leak check the system with dry nitrogen. We recommend using the 3-stage leak check method. The first stage should be at 200 psi, for a minimum of 8 hours. The second stage should be at 300 psi, for a minimum of 8 hours. And on the third stage, you should use 450 psi of dry nitrogen, and it should hold for a minimum of 24 hours. This portion of an ECOi installation is the most critical. If you do not perform a thorough leak check at this time, it can become costly and very time-consuming to find a leak later on. Once you are sure that you do not have any leaks in the refrigerant lines, the system will need to be evacuated down to a minimum of 500 microns. A micron vacuum gauge should be used to ensure that you have an accurate measurement. The triple evacuation method is strongly recommended. If you have combined condensers, also evacuate the oil equalization line. Always apply power to the condensers for a minimum of 12 hours before starting up the system. The UME is a heat pump. It will only have liquid and suction lines. The UMF heat recovery unit is capable of simultaneous heating and cooling, which is why you will find that it has a discharge gas line. The oil equalization line is only used when combining condensers. If you are installing a heat recovery system, solenoid boxes must also be installed to provide simultaneous heating and cooling. These are the main components that are included with the solenoid valve kit. You will find the solenoid box, the relay box, and the mounting bracket for the relay. There is also a 5-foot gray cable, which is not shown in this picture. When brazing, purge the air from the solenoid box, but turn the nitrogen flow off before brazing the connections. The superheated nitrogen will damage the seals in the valves. It is also recommended that the solenoid valve boxes be installed in a hallway and not in a noise-critical area, so that the solenoid's clicking noises cannot be heard. The solenoid box can be mounted up to 98 feet from the air handler. The supplied gray cable is 5 feet long. This cable connects the relay box to the air handler. This is the reason that the relay box must be mounted within 5 feet of the air handler. Connect the gray cable into the 3-way plug on the air handler's circuit board, and plug the opposite end into the relay box. Please note, there might be an existing cable plugged into the 3-way connector, located on the air handler's circuit board. If so, plug your gray cable into the end of this existing cable. On terminals 1 through 5, attach 18-5 wire, and run this to terminals 1 through 5 of the solenoid box. This connection is polarity sensitive. Do not cross these wires because the solenoid box will not operate properly. The 18-5 wire required for this connection does not have to be shielded. This is the 3-way connector located on the main board. It can be found on all of the indoor units. This is the solenoid valve box. Terminals 1 through 5 are for the control wiring that connects to the relay box. Above that are the terminals for the power supply. If local code permits, you may connect the high voltage from the air handler to the solenoid box. So let's review. The 5-foot cable that is included connects to the relay box from the air handler. The relay box then connects to the solenoid box via 18-5 T-stat wire. The maximum allowable distance is 98 feet. The power supply for the solenoid box is 208-230 volts. Multiple indoor units can share the same solenoid box, as long as the rated capacity of the solenoid box is not greater than the total capacities of the air handlers. These group units will always share the same set point and operate in the same mode. If one of the units achieves set point, it will go thermal off, but the other units will continue to run until they reach set point. A good application for this would be a conference room or a large common area. In this example, each unit has its own local controller. An input made to one controller will change the others. The same rules apply, whether you have one controller or multiple controllers. They will all share set point and mode.